Welcome to our last lecture. This one is on Mongodb, which is the leading NoSQL database. It's in the top 10 of overall databases in general. Very popular and widely used system. So it's based on JSON structures, which are a streamlined version of XML. And JSON stands for JavaScript Object Notation. Just like a relational database is organized around tables of records, a MongoDB database is organized around collections of documents. So, MongoDB is an open source and document-oriented database. Data is stored in JSON-like documents. It's been designed with scalability in mind, and it has dynamic schemas. So we see an equivalence between the different objects in a MongoDB database and a relational database. Both of them will have multiple databases that they can access. Each database will have multiple tables or collections. In MongoDB, the equivalent of a table is known as a collection. Each table in a relational database will have a row or record, and each item in a collection in MongoDB will be a document. Each of the records has columns or attributes. Likewise with the document, it has fields. So there's a general equivalence in terms of what we see in these databases. So when we download a MongoDB, we're going to get several executable programs. MongoD is the database server that we would run. Mongo is an interactive shell that uses JavaScript and the MongoDB language to query the database, update the database, and interact with the database more generally. MongoS is our sharding or partitioning program that we get with the system. So MongoD is the database instant. MongoS is sharding processes. It's analogous to a database router. It processes all requests and decides how many and which MongoD database instance should receive the query. MongoS collates the results and then sends it back to the client. So MongoS interacts with the MongoD instances in the distributed database framework. Mongo is an interactive shell. It's a fully functional JavaScript environment for use with a MongoDB. You can have one MongoS for the whole system, no matter how many MongoDs you have. So you can have one Mongo sharding program, MongoS, and you can have hundreds, well, let's say dozens of MongoD database instances. Or you can have one local MongoS for every client if you wanted to minimize the network latency. So here's the hierarchy of MongoDB objects. It's very similar to the hierarchy we see in relational. Databases, collections versus tables, documents versus records, fields versus attributes. So I mentioned that MongoDB is document-oriented. There's also graph databases that are quite popular as well. Neo4j is one of the leading graph databases. Obviously, as we discussed in our last lecture on distributed database technology, MongoDB has very high availability. It can automatically partition your programs for you. MapReduce is a way for handling aggregation, and it was the original way that most of the NoSQL databases did this. Now, in response to relational database programmers and designers, they've added an aggregation framework functionality. So a lot of the things that you used to do in MapReduce, you can now do in the aggregation framework. MapReduce is still useful for very complex actions that you want to do, but aggregation framework is a very easy to use, and it's intuitively obvious to relational database programmers because they use that aggregation framework in their relational systems. So when we get into Mongo, we'll use a particular database name, and then we can access a particular collection. So if it's the collection analogous to a table is named CMSE491, we would go db.cmsc491. And we can find instances in the collection, in other words, documents, with the find command. We can also put search filters in our find command to help us find a particular document. We can also find just one record so we can see what the structure of the data looks like. And we can insert things into a collection using the insert command, and we format it as a dictionary, which is also known as a JSON structure. So to start MongoDB, we get into our directory, our bin directory that has the executables, the MongoD, the MongoS, and the Mongo. And we just type in MongoD space -- db path, and then give the path to your database. So on a Windows machine, it'll look something like this: MongoD -- db path C:\\, and then the path where we're going to put our database, let's just call it MongoDB_data. So that's going to get our server going. Once the server's going, we can start up a client. So remember that the MongoDB client is Mongo. Then we connect to a database and view a collection, so you just fire up Mongo, and it will go by default to the local database server that we started. And we can use a particular database, and then we can get a particular collection out of that database and start using functions that for accessing and aggregating the information in that particular collection. So let's take a look at how we're going to install MongoDB. And I'm going to show how to do it on the PC because that is a little more involved than it is on the Mac. I have instructions for both Mac users and PC users on what to do, and this is just a video recording of that process. We'll also have a Zoom session, and I'll be able to demo the same thing there. So let me pull up our Sakai website. So under resources on the Sakai website, let this load, we've got a folder called Mongo, and that's under lectures. So go to the folder Mongo, and you can see we've got a Mac section and a PC section. I also have 2 YouTube videos that give some lessons in how to do MongoDB operations. So you might find those useful. And of course, in the lab, we have what we need to do for that anyway. So let's go to the PC. And here's the lab instructions, so we can download that. Now with the PC, you're going to need to install the Visual C redistributable. So you'll have the Visual C redistributable, click on that, and then it downloads, and in my browser I can just pick it up here. Yours might say something like open folder, other particular approaches to doing it. But my browser that I'm using, which is Chrome, gives me this. So I go ahead and click on that, and you can see it lets me have the option of starting the installation of the Visual C redistributable. So go ahead, fire that up, let it install that VC redistributable. Then once that's done, then download the MongoDB pc.zip. So you click on that. Again, it's going to show up here. And I'll move this down a little bit. So you can see what's in the zip is the bin file, which has these programs that you get with MongoDB. So what I'm going to do is I'm just going to copy that right over to my C drive right at the root. So on my C drive I've created MongoDB, and then I just copied the information or the programs and folders from the zip file into MongoDB. And I've got my, my bin file now on my C drive. Then likewise, I'm going to just create an empty folder called MongoDB _ data. And MongoDB _ data will actually be filled in by Mongo. All you have to do is give it an empty database folder. It does the rest. Or just an empty folder with the name that you want for it. I called mine MongoDB _ data. Then we can start a terminal window, and I'll go to MongoDB /bin . And I type in MongoD, which is our database server, and I give it the path where it's going to store the database information. --db path tells it that this is the parameter for the database path. And then I just give it the path, C:\MongoDB _ data. And then hit enter. And you can see that it's fired up and it's now waiting for connections. So what I'll do is I'll start another terminal window, and I will go to MongoDB /bin. Then I will type in Mongo, and I'm now connected to my Mongo database server. So I'll issue a command, show DBS, show DBs, And I can see I've got a database in here, but I'm going to create a new database by just saying use MBA 588. Now I've created a new database called MBA 588. And I'm going to go ahead and put a record into that database. So I'm going to create a collection called test set, and I'm going to insert a record, and it's got 3 fields. Name is one, age is another, and gender is the third. And I'll put in my particulars, George, 67, and M, and then I'll hit return. And now I've added a record to my database and to that particular collection test set. And we can find we can find all our records using the find with no arguments. And of course we only have one record in there. And likewise we can also give it a filter so that it'll just look for the one particular record. And here I use the filter name with the name of George, and then it picks that one. And also if I do show DBS, we see that now we have a database out there called MBA 588. So this is what you'll do for your graded exercise for the last lab in the course. And it's graded exercise 5. So you'll be doing just this, very straightforward, just to get you used to the idea of how to install Mongo and how easy it is basically to create things in it. Oops, let's get back here. Okay, we also started Mongodb after we installed it. So let's take a look at JSON. This is the format that is used for storing records in Mongodb, just like tables is the format for storing records in a relational database. So in JSON, the data is in name-value pairs. A name-value pair consists of a field name followed by a colon followed by a value. And so in our particular example here, let me, okay. Right there. I have name value pairs. Name is the name of my field, name, and then George is the value. Age is the name of a field, 67 is a value. Gender is the name of a field, and M is a value. So these are name value pairs, and they're in brackets. So this is what's known as a dictionary or a JSON object. In brackets, you've got these name value pairs. So data is separated by commas, as we saw there, and the curly braces hold the objects. If you want to deal with arrays, then you would use brackets to indicate an array of values. And unlike SQL, you can have arrays of values in your documents. So JSON is a data exchange format and it's widely used in NoSQL databases. And JSON came about because the earlier data representation, known as XML, was effective, but it was highly verbose. And so with JSON, you get the same level of effectiveness as you did with XML, with about half of the data characters that you're sending over an internet connection or some network connection. So just a takeaway, a JSON object is enclosed in curly braces, and it's a series of name-value pairs separated by commas. And this gives you the same metadata that you would get with a table. But with a table, you need to have the schema to tell you what each particular field value is. And if, for example, you'd have a column called name, and a column called age, and a column called gender. Here, you send the name of the field and the value at the same time. So this is a JSON object. It's a dictionary in curly braces, name-value pairs separated by comma. Okay, so that's a quick introduction to JSON objects. And dictionaries and JSON objects are what you'll find in document databases. So let's look a little bit about the Mongodb architecture. So Tengen was a company that originally developed MongoDB, and its vision is to leverage the work that Oracle and Microsoft and others have done over the last 40 years with relational databases. No reason to discard decades of proven database maturity, so MongoDB picks up where the others left off. It combines key relational database capabilities with the work that the internet pioneers have done to address the requirements of modern applications. It uses a very expressive query language, and users should be able to access and manipulate their data in sophisticated ways to support both operational and analytic applications, just like we had in relational databases, and we had an entire lecture on analytics, online analytic processing. So MongoDB has a strong consistency. Some applications may need to immediately read what has been written to a database. It's much more complex to build applications around an eventually consistent model. That imposes significant work on the developer, even for the most sophisticated engineering teams. So when you have something with a proven track record like Mongo, it's valuable. It also has enterprise management. Databases are just one part of the overall information technology infrastructure in an organization, and all of them, be they relational databases or document databases like the MongoDB NoSQL database, have to integrate into your existing infrastructure seamlessly. So organizations want a database that can be secured, monitored, automated, and then integrated in with their existing technology. and that you don't want to overburden their staff with this as well. So MongoDB has a flexible data model. NoSQL databases emerged to address the requirement for data we see dominating modern applications, which is availability and high volume. So it doesn't matter if it's a document database, a graph database, or other NoSQL database types. All of them offer a flexible data model, making it easy to store and combine data of any structure, and at the same time allow dynamic modification of the schema without any downtime or performance impact. You can scale horizontally using sharding. NoSQL databases were all built with a focus on scalability, so they all include some form of sharding or partitioning. This allows the database to be scaled out across commodity hardware deployed on-premise or in the cloud, and that enables almost unlimited growth with higher throughput and lower latency than you would have with corresponding relational databases. So NoSQL databases are designed for continuously available systems that provide a consistent, high-quality, user-friendly experience for users around the world, which is our audience in many types of applications. They're designed to run across many nodes and to include replication to automatically synchronize data across servers and geographically dispersed centers. MongoDB has a flexible document model, and it really presents a superset of the other models. It allows data to be represented as simple key-value pairs, also as flat table-like structures that we would see in relational databases, all the way through to very complex documents and objects with deeply nested arrays and subdocuments, something we can't do in relational. It has, of course, an expressive query language, JavaScript. Documents can be queried in many ways, with simple lookups all the way to sophisticated processing pipelines for data analytics. So MongoDB has multiple storage engines, and MongoDB allows users to mix and match these multiple storage engines within a single deployment. So traditionally, multiple database technologies would need to be managed to meet these needs, where you've got different database requirements and you want to use a different engine. And in Mongo, you can have multiple engines running at the same time, some of them tailored for specific things. So MongoDB, beginning with version 3.4, ships with 4 different storage engines, and all of them can coexist within a single MongoDB replica. The first is the default Wired Tiger. Wired Tiger is something that was actually done by the user community. And it had better overall performance and storage efficiency than the original MongoDB engine. You don't get this with the free version of Mongo. You get Wired Tiger with the free version of Mongo. You do not get the encrypted storage engine. So that's something that protects highly sensitive data without the performance or management overhead of a separate file system encryption. So the encrypted file storage engine is a paid, when you pay for the database, you get that. The in-memory storage engine is likewise something you get with the paid versions of MongoDB. And then finally, the original MMA database engine, MMAP, MMAP, was the one that was used prior to version 3 MongoDB database releases. So, Mongo extends the popular JSON representation that we just looked at to include additional types. Mongo documents contain one or more fields, and each field contains a value of a specific type, including arrays, binary data, and subdocuments. Documents that tend to share a similar structure are organized as collections. And it may be helpful to think of collections as being analogous to a table in a relational database. Documents are similar to rows, and fields are similar to columns. And here we have an example of a blogger and how they might set things up in a relational database. The data model would comprise multiple tables that we see on the left-hand side. To simplify the overall example, let's just assume that there's tables for categories, tags, users, comments, and articles. In MongoDB, the data could be modeled as two collections, one for users and the other for articles, and we see this on the right. In the blog document, there might be multiple comments, multiple tags, multiple categories, each represented as an embedded array. And of course, you can't do that in relational databases. So MongoDB has a dynamic schema. So MongoDB documents can vary in structure. Fields can vary from document to document. So there's no need to declare the structure of documents to the system. In a sense, documents are self-describing. If a new field needs to be added to a document, then the field can be created without affecting all other documents in the system and without updating a central system catalog. So we have document validation to help us control for data quality. It's important that controls be implemented to maintain this data quality, especially if the database is shared by a number of different applications, and especially if it's worldwide. So in MongoDB, you do have document validation within the database. Programmers can enforce checks on document structure, data types, data ranges, and the presence of mandatory fields. So, as a result, database administrators can apply data governance standards while developers maintain the benefits of a flexible document model. So we did a query, and we'll go ahead and bring this up and do it again. So we'll go up here. So here's a query. I'm using the current database. The test set is the collection, and I want to find a record that has the name field with a value of George. So I run that query, and up comes the record that we put in. That's an example of a query. So MongoDB provides drivers for all the popular programming languages: Java, JavaScript, Microsoft's .NET Suite, Python, Scala, you name it. They've got plugins and drivers for those languages so that you can write code in those languages and access MongoDB. In Python, we use a library called PyMongo, and it lets us write a program and access the PyMongo database in a very straightforward manner. The MongoDB query model is implemented as methods or functions within the API of a specific programming language, as opposed to a completely separate language like SQL. So we would do things a little different with SQL than we do with PyMongo, for example. For non-driver tools, the Mongo shell is a rich, interactive environment, uses JavaScript. And then there's additionally MongoDB Compass, that is a GUI that's very sophisticated, offering rich schema exploration and management with both MongoDB Professional and the MongoDB Enterprise Advanced versions. Again, those are ones that cost money. So there's a number of different MongoDB queries. We have key value, and that's the queries return results based on any field in the document, can be the primary key. Range queries return results based on values stated as inequalities, greater than, less than, or between. Geospatial queries return results based on proximity criteria, intersection, inclusion in a specific region, such as a line or a polygon you might draw on a map. The aggregation framework queries return aggregations and transformations of values by doing functions like count, min, max, average, similar to the functions we have in the SQL group by statement and the aggregate functions we have in relational databases. You can also do joins and graph traversals, map reduce. Queries execute really complex data processing. It's expressed in JavaScript and executed across the data in the database. Just as we have with relational databases, we have indexes in Mongo. Indexes are crucial for optimizing read performance. So if you're going to be doing a lot of analytics, you're going to want indexes, a lot of indexes, to speed the read performance you have. If you're doing a lot of updates, you might want to reconsider how many indexes you have, because every time you update a record, you have to update every index it's a part of. So you're adding to your overhead in that regard. So it can have unique indexes where it makes sure that a particular field you put the index on, you can never put a duplicate value in there. So in a sense that one of the things we are looking for in a primary key. The other is it's not null. We can also have compound indexes. It can be useful to create compound indexes for queries that specify multiple predicates. With a compound index on last name, first name, and city of residence, queries could efficiently locate people on all three of these values that are specified. We can also even put an index on values within an array that's in a field, in a document, in a collection in the database. And then we have time to live indexes. In some cases, data should expire out of the system automatically. Time to live indexes allow the user to specify a period of time after which the data will be automatically deleted from the system. Geospatial indexes are used to optimize queries related to a location within two-dimensional space, such as projection systems for the Earth. This is one of these systems. Believe it or not, SQLite is another one that can be hooked into QGIS and ArcGIS, some of the premier geographic information systems out there. In addition, we can do text search with a text search index. It provides a specialized index for text search that uses advanced language-specific linguistic rules for stemming, tokenization, case sensitivity, and stop words. And then queries that use the text search index will return documents in relevance order. One or more of the fields can be included in the text index. So MongoDB has extensive security capabilities. Authentication is simplifying access control to the database. You're telling the database who you are with authentication. Authorization, well, when you can authenticate yourself with something you know, for example, user ID, password, you can identify yourself with something you have, user ID, and you've got a key fob on your keychain. Or it's something you are, user ID, and then a biometric scan of your fingerprints, your eyes, or a face recognition. Authorization is where we say which users have which permissions to our resources. So user-defined roles enable administrators to configure really granular permissions in MongoDB for a user or for an application. Additionally, administrators can define views that expose only a subset of the data. So this is very similar to what we have in views with relational databases as well. So for regulatory compliance, security administrators can use the native audit capability in MongoDB to track any operation taken against the database. It's most often accomplished by means of system logs and database journals and the auditing of these records. And finally, we have encryption. Obviously, this is in the paid versions of MongoDB. Data can be encrypted on the network, on disk, and in backups. With the encrypted storage engine, protection of data at rest is an integral feature with the database. So this is an introduction into MongoDB. And just again, to summarize, your task as a group is to read the instructions under MongoDB PC. The instructions are called mongo1.docx. And basically what you're going to do is you're going to download and run the Visual C redistributable, and then you're going to download the MongoDB zip file. You're going to unzip it and copy the bin directory to a directory on your C drive. I just copied it. I made a directory called MongoDB and copied the bin drive to it. Then you're going to make an empty directory that's going to hold your databases. So that will be MongoDB underscore data for me. But I mean, it can be whatever you believe you want to call it, whatever you think is the best. And that's going to be your assignment. And then you're going to insert a record, find a record, and then find a record using a filter. Okay, so that's it for databases, MongoDB databases. Thank you.